Okay, so today we're going to talk about carbon. Carbon is a tetravalence, meaning it has 4 valence electrons. And remember, valence electrons are the electrons on the outermost shell. They are the electrons that interact with other valence electrons. Its most frequent partners are hydrogen, oxygen, and nitrogen. So, carbon chains form the skeleton of most organic molecules. And okay, hydrocarbons. Hydrocarbons are organic molecules with only hydrogen and carbon, so they won't have any other element except hydrogen and carbon connected to each other. So fats have hydrocarbons. And this is an example of a hydrocarbon, and it's methane. Okay. Isomers, these are structural isomers. Structural isomers have the same molecular formula, but different structures and properties, which means they have the same formula, which means they have the same amount of each element, but they have different structures, meaning they have different shapes, as you can see. Okay, so now geometric isomers. Geometric isomers have the same covalent arrangement, but different spatial arrangements. And what that means is they have the same shape. Can you see it? Okay. They have the same shape, but the elements are on different parts. For example, here you have your hydrogen, here you have your hydrogen, here you have your hydrogen, but here it's different. Here you have CH3. See it? So that is a geometric isomer. They are in different spaces on the same shape. Okay. N-anomers are isomers that are mirror images of each other. So these two, for example. So if you took it this and you flipped it, then it'll be like that. Sort of like that. If you flip it like that, it'll be those. They're mirror images. And they can have completely different effects from each other. For example, ibuprofen has an isomer. So ibuprofen can help with headaches and body aches, but its isomer does not. So that's why it matters. You can't just use the mirror image of something. Okay, function groups, they are the chunks of organic molecules used in chemical reactions. And these are the ones that we're going to use in the class. So we have hydroxyl, and the question marks can be anything. So it has to be these elements in this way connected to a different element. So the question marks can be anything, as long as everything else is the same, and the shapes have to be the same as well. All right, so we got hydroxyl, methyl, carbonyl, carboxyl, amino, phosphate, and sulfhydryl. And remember, the question marks can be anything else. As long as you see these parts, then that is what it is. Okay, and finally, ATP. ATP is the primary energy transferring molecule in the cell. It is an adenosine or adenosine, which is right here. That's what it looks like. Attached to a string of 3 phosphate groups, which is where triphosphate comes from, because it's 3 phosphate groups attached to adenosine. And this is what adenosine looks like. So if you see this and 3 phosphate groups attached, that is ATP. Okay, have any questions, you can send me a message on the GroupMe, or you can email me or leave a comment below. Thank you.